Oh, right, yeah.
You just like zoom in and out and stuff and like turn it. And... Yo kids, it's me, Captain Science! Today I'm gonna be teaching you some epic science experiments! Yeah!
So what is boiling, guys? What does it start out as?
A liquid.
A liquid, and what does it go to? Go ahead.
A gas.
A gas. So boiling goes from a liquid to a gas. We're gonna get some isopropanol here. Isopropanol boils at a much lower temperature. It doesn't take nearly as much energy to get this boiling. And you might see, if you look in here, I'm gonna put it in here. You see how, if it's in those rings, see how it skitters around?
Those glasses, remember, let's do a flashback. Like
that. Oh, that's bad. Oh, that's real bad. Ah, that's real bad.
I know.
look at the flames.
Look at the flames.
5 stars.
I can identify the different rainbows. Where are you at?
Remember these? Let's take a look.
Like a huge nuclear bomb. A huge nuclear explosion. And it's pushing out because it's exploding. Well, what's keeping it together then? Because it doesn't just explode away. That's right. The big idea we learned about yesterday, gravity, keeps the sun from exploding out into space. Dr. Nidegger, I want to point this out. She's pointing to Orion. There are 3 stars that make up his belt. There's 3 or 4 stars that make up his sword. There's 2 on the bottom that make up his feet. There's 2 at the top that make up his shoulders. That big orange ball that you see represents the size of Betelgeuse compared to the size of our sun.
Whoa.
And you can see that Dr. Baradovich, what he's doing is he's shining this light right here onto our detector, which is over here. And when he does that, we see a bunch of mountains show up. You see that big peak right there? That's stuck somewhere between 400 and 500. That's about 450, yeah? We got some light at 450. So by using this machine, we are able to measure the wavelengths of light, they're really tiny though, in units of nanometers. We're going to try to measure the wavelength of this red light. Dr. Nidegger is going to tell us what our wavelength is, and maybe put a little color up there for us.
About 630, 625.
Yeah, 630, 625, that's sort of red, orange, white. You know what, let's test this idea. Is red always that way? Let's try this thing. Let's get a different red light. That look red?
Oh, wow.
Okay, hey, look at that. It's in the same spot, isn't it? So let's try. Why did he show up when we're playing with red light?
Because he is a red light. He's on the dark side.
Can we measure the wavelength of that? He's on. Let me hold his lightsaber. This is awesome. Look at that. That's the same spot. That's the same. Let's have a hand for Darth Vader.
Pretty
No entry allowed.
Me and Vader here.
And I can.
Aunt Sam, I am. That's cool, Vader. It won't fit on you, sorry. You better run.
No entry allowed, huh? Why do you always buy stairs?
T-pose. You guys
Who did do that?
Okay, I run to the field, but then I'm gonna keep running somewhere, right?
Run to like the back.
Stop.
Then once I start chasing you,
Run.
like just run around in like circles and stuff. Then once I start chasing you, like run to the that side of the building.
Okay, and then go into the basement entrance?
Yeah.
Okay.
You ready?
You ready?
Alright.
There's a big drop off right there.
That's like
I think you're slipping and fall.
we'll meet you over there. Be that fast?
How was that? Wow.
You didn't want to stop because all the kids were like, why? Batman wants his money back.
Where is it? Where were you getting?
Right there.
Skittles?
And I'm going to go ahead and give this element energy by sending electricity through it. And I want you to look at that light that's being given off by that element through those glasses. We're seeing through those glasses to these patterns that we see for these different elements when they give off light. How many think it contains neon? Oh wow, that's a lot of you. A lot of people think it contains neon. Well, most people said that there's neon in that tube, and most of you are right. It is neon gas inside that tube. And this, if you think about it, is remarkable. That's absolutely remarkable. You all are sitting in your seats, and all you are doing is analyzing or looking at very carefully the light that's coming from the atoms that are giving off the light in this tube, and you didn't do any chemistry experiments. All you did is look at the light, and you figured it out. How many think that's hydrogen in there? How many think it's helium? Any votes for neon?
It's
You already know what neon looks like. How about sodium? How about mercury? Those of you who guessed hydrogen, you're correct. Hydrogen, few of you again. How about mercury? Quite a few of you think mercury. Okay. Well,
Yeah, that's what I'm
actually, this is what happened. Scientists were looking at the light that was coming from the sun, and in fact, the element helium had not been discovered. And they're looking at the light from the sun, and some scientists were saying, you know, that kind of looks like sodium. So some folks thought maybe there's some sodium on the sun. And some other folks thought, well, maybe it's mercury. So some folks thought that there was mercury on the sun. And then doing very careful measurements, which had to be done, because I think we can see it's really kind of tough to tell which of the three it is. There was one particular scientist who said, you know what? There's this bright yellow line in helium, Dr. Neidegger's pointing at it, that no one has ever seen that wavelength before being given off by one of the elements. And this scientist said, you know what? Because no one has seen that before, I'm going to say that that is an element that nobody has discovered before. And he named it. He named that element Helios, which is the Greek word for the sun. And over time, the word Helios got changed into helium.